Good afternoon, everyone, and welcome to my presentation. Yeah, as introduction said, we're going to talk about isolating development environments. You can see there the link to the GitHub. For what matters, you can also sign off now and just check the GitHub, and it will be as well. But if you would like to enjoy my company for the next hour, I can maybe guide you through it, and then you can play around with it later. All right, so let's go. About myself, my name is Petrella. Professionally, I'm a developer and a Scrum Master. I just see myself as a developer no matter the role I take. I like exploring with different languages and different methodologies. I am also a PC gamer and a very amateur bass player. I have a strong belief in Kaizen, which is the practice of continuous improvement, which is also what led me in my journey to approach my machine using Linux and using containers for developing software. So, more in detail, what we're going to talk about, we're actually going to talk about isolation. So I will show you how to set up some very simple containers that contain an IDE and a browser. I'm going to show you how you can integrate those containers with the desktop manager in order to make the experience seamless so that you don't think that you're using something different than normal application. I will show you also how to set up multimedia so that you can actually use your webcam or your microphone. And then we're going to some more advanced topics like how to set up a VPN and how to take advantage of this particular architecture to do some nice things with VPN. And then we're going to go into some further integration with the system, which, again, make the experience more seamless and things. It's just easier in your normal life. So, okay, but why would I want to do this? Like the first question, why? Why go through the hassle of putting your IDE in a Docker container and your VPN in a Docker container? Well, the reason is that I have a single laptop. I like to use a single laptop under most circumstances, and I use it for both my private life and my professional life. And the projects I do for fun are usually not compatible system-wide with the projects I do for work. So I want to avoid the system-wide applications as much as possible so that I can separate the configuration and avoid conflicts in many ways. So that's really the main reason. Another reason is just convenience. Sometimes when you are at a customer, you have to do some strange configuration to get things working. Maybe you have a customer that requires Kerberos authentication. Maybe you have a customer that doesn't allow to use their VPN to browse the internet, things like that. And these configurations can be a bit complicated. And if I change machine, it can be hard to restore. Like I could waste a couple of days just to get things up and running. I don't want that. So I want something that I can just run a script and have everything ready in 1 hour, 2 hours at most. And of course, I really like separation between private life and professional life, and I want that to be reflected in my machine. So I want, again, true separation between things. I want to have control on which parts between the applications are shared. And yes, this approach works for me. So, okay, but why Docker specifically? So why don't you use other technologies like Snapd or Nix? Well, main reason is that I'm familiar with Docker. I approached the Docker and containerization for work. I used it for a few years already. I know how to configure it. There are a lot of guides around. There are a lot of containers to start from. And one thing that I like about Docker is that it's really easy to iterate over an image. So for these images that we're going to build, I really don't strive for optimization. I don't want to optimize the space. I just want them to be easy to configure. So I don't care making extra layers. That doesn't matter. But if I can add new library very easy to an existing image, that's a win for me. Okay, enough with introduction. I already talked too much. For what I wanted to say in this presentation, I want to actually spend most of the time here showing you stuff because Yeah, I could talk about it, but it's better if you see it. Show don't tell, as we say. So let's start with the very practical, and let's throw some foundations to this whole project. What we're going to do, I'm going to show you. So all the containers that I will build, they are based on Ubuntu X11 container. At least all the containers that require graphical user interface. The reason for that is because this way we can share libraries. I can make a template folder inside, a folder structure inside. I can enable 3D acceleration and add some utilities that I'm going to use on any container anyway. So we're going to have this image based on Ubuntu that is going to include some libraries for 3D acceleration. So let's start with that. One word of warning, I'm a terminal kind of guy, so you will see Emacs and a shell pretty often. Of course, you do you if you like to use Visual Studio to edit this stuff or anything else that works as well. That goes without saying. So first, a bit about the project structure itself. So this is just where I checked out the Git, and the tree structure looks like this. We have a Docker folder where all the Docker files are and all the scripts that are needed for the Docker files to work properly. We have a home folder that is where all the scripts are, all the scripts that I'm going to use to create Docker containers, to launch them. You're going to find all of that then. And then there is a workspace folder, which represents the home of each container. Again, remember, I want to isolate things, so each container will have their own home folder. Okay, there is some extra bit, actually, and we also have this small file here, which will be relevant later, but it's good to know that you have here. So this home folder actually reflects the home structure on my Linux machine. We'll get to back later, but let's continue for now on setting up a base container. So this base container does very few things. The first thing it does, it creates a new user. So what I do here, I pass my user ID as an argument when I build the container. And what this means is that if the user does not exist, it creates a new user and sets bash as its main shell. And so that happens here. Then it creates a workspace directory and a home directory that is going to be owned by the user. So it's so every Docker container has the same directory where they can work on. And it's also adding the group video to the user. This is going to be useful later when I show you how the webcam works. So base container contains all this stuff so that you don't have to worry about it in the other containers. I also install some libraries and utilities. I really like the fish shell, so I'm going to use that in most containers. I also picked it for this presentation because I think it's a bit easier to read if you're not really familiar with scripting compared to Bash. So all the scripts that you're going to see are made in fish, but of course you can achieve the same functionality in Bash. wget is always useful to download stuff. Vim, because you never know when you want to edit some files. Bat is just a cat on steroids, basically. It has highlights and line numbers, so it's useful to read files when you just want to check something quickly. Then we go to the more graphical stuff. We have font config to install fonts, because otherwise all our software looks ugly. X11 apps to test that everything works. And then some libraries for 3D acceleration, and libpulse for audio. So this allows the Docker containers to work as a Pulse client. So under Linux, they will support audio. PV is just a utility to show progress bars. I use it when creating containers sometimes just to make the output a bit cleaner, so I know what's going on without having a lot of output that's just daunting. After all this is done, it sets the work directory as the home, and it sets the user to UID. So this means that when I run this container, it will be with the user ID that I passed. When you inherit from this container, it will be with the user ID that was passed. So yeah, that's a deliberate choice. I didn't want to finish up the container with the root, which is the default that would have happened otherwise. Okay, so this is the Docker file. Before I show you how to build it and how to run it, let's go a bit to the scripts that I made to do that. And sorry for my keyboard, I have a mechanical keyboard. I like clicky stuff, so you're going to hear a little bit of noise. So we have the build script that is very simple. It determines an image name for the Docker image. Then it determines the UID that is passed of the user that is running, and it just creates the image based on the UID. That's all there is to it. Base name is a utility that takes the file name of a path. It takes the latest, the leaf of the path. So what does it mean? It means that if I try to run this script and say home bin build, and I want to build Docker Ubuntu X11, it will create an image named Ubuntu X11. It's just a convenient way, so I don't have to remember image names. They will all have the same name as the folders. Of course, this was super fast because I already built all these images before, so that we don't have to look at the screen running stuff while doing the presentation. So yeah, the build script, there's nothing fancy about it. Okay, but now let me show you this image in action, and then I show you how to run it. So first see something, and then I explain you how you get to that thing. So okay, I have a small script to actually launch it. I launch it in interactive mode, so I'm passing a -i there, and I'm presented with a shell. So in this case, it's in workspace home. My UID is 1000, which is the same as the UID on my machine, on this user that I'm using. So, and this shell has X11 configured. So you see I can move X size, it follows my mouse, so, and it behaves like a window in my desktop environment. That's great, but it also has the acceleration. So of course you see this static probably in your screen, but it's going at 2000 frames per second. So that's good. Not great, but I'm running an Intel graphic card, so I can't expect much more, to be honest. But still, it's really accelerated, and this is very important if you're running something like a browser and you want to see YouTube videos on it. It's always good to have acceleration anyway. Okay. So we have a Ubuntu container that is actually running stuff. Great. How you get there? I saw guides on YouTube, or I saw guides around the internet. Usually this is achieved by having a privileged container. I don't like that, so I tried to not have privileged containers at all for this presentation. I cheated a bit in the sense that in my actual usage, I do use privileged containers, but I still try to keep them to a minimum. So everything starts with this base n, this base.devgen. So when I have a lot of scripts that are very, very similar, I really like this approach of having having a symlink for scripts and then determining some arguments from the name of the link itself. So if I see, if I show you Ubuntu Docker, this one, you see that this is just a symlink to base.devgen. So that, which is this script. What this script does, to be honest, not much. So it sets the script variable. It extracts the script. The script variable is just the name of the script. And in Fish, you do this by calling status -f. Then argparse allows to take the -i as an argument. and it puts it inside, and it sets a variable for it. So I can check if the flag I was posed. I can say that the mode is interactive in Docker, otherwise it's running in daemon mode. So for instance, if I would run Ubuntu without the manus I would just be kicked out because nobody is keeping the shell open. Then what happens here is that it goes inside the directory of the script just to make sure that we respect the, so that I can assume in the environments that we're always in the same directory. It sources the base.env file, and then if there is a script.env, so env file with the name of the script, it sources that file as well. So this allows us to override some directories. It allows us to override some functions. This will be useful later. I will show you one. Okay, after that, it just takes the container name from the script, the image name from the script. These are all functions that I sourced from the base N. And then it uses another function to determine parameters and extra parameters. It removes the existing container, if any, and then it just runs the new container, passing the mode that I set based on the flag, the parameters that we determined calling these functions, the image. I'm always taking the latest image. This is one of those things that is not really a good practice in production, but for my purposes it works, so I don't see why I should not do it. And of course, it passes every other argument that was passed to the script to begin with. So that means that, for instance, I can actually do Ubuntu xgen xize, and it didn't work, of course. Shame on me for trying something in a demo that I didn't try before. Anyway, but it works for other things I actually tried, so we will get back to it later. Okay, so what do we define in base env? And why do I have Docker params and Docker extras, more importantly? So before I go to the file, Docker params passes all those parameters that are common, that have a high chance to be common between all the Docker containers. Stuff like work folders, volume mounts, device mounts, X authority, these kind of things. They are all passed into Docker params. And Docker extras allows to do some overrides so that I can override only the things that I really care about and not those things that I know that I have to pass to everybody anyway. So let's go to base env. So okay, a lot of scripts that are very simple, just an easier way to extract stuff. So the image name is just the name of the script before the dot. So in case of Ubuntu X11, that would be just Ubuntu X11. And the container name will be the name of the full script, the base name of the full script. That's all there is to it. Parameters are a bit more interesting. So what I do here, I first set some variables. I take the UID, again, because I want to run the containers as my current user. I take the workspace so that I know where the workspace folder is. And by workspace folder, I mean exactly this folder here. This is where all the images will be created. And in fact, I create that folder as well. So it creates a folder with this image. mkdir-p just doesn't do anything if the directory already exists. And then there are quite a lot of parameters to pass to the Docker container. That's why I have a base function for it, so I don't have to worry about it anymore. So the first thing is, of course, the user ID, so that we know that everything is passed correctly. And then I pass some environment variables that are needed for X11 to work, so to actually display graphics. And you have the display variable, the X authority, and the XDG runtime directory. The runtime directory is usually where the sockets are for your Linux installation. So it's where it will find, for instance, the Pulse audio socket. The X authority is also inside that directory. So that's why it's important to pass it as an environment variable so it knows where to find it. The X authority are the permissions to access the screen. The display is the actual display. where I do it. So for instance, if I do echo on $display, you see that it's a column 1, and I want this to be passed to the Docker image. Then I pass some environment variable here, vblend mode. This was just to disable vertical sync, so I could show you the full frame. Otherwise, it would have been 60 frames, and you can achieve that without acceleration. Then we pass the device, the DRI device, which is used for 3D acceleration. We pass the socket for X11, which is, in my installation, is in tmp.x11 Unix. In other installations, might be somewhere else. We pass the full runtime dir. So the runtime dir has to be both passed as a volume and defined as an environment variable. You could use a different runtime dir for the Docker container. I just didn't want to do it. And I pass another device, video 0, that is my webcam. Then I mount some volumes to make things pretty, so themes, icons, and fonts, and the workspace folders. So my actual home will be mounted under workspace/shared, and the home of the container will be mounted under $workspace. So these directories that I created here. In Docker extras, there's just hostname equals container. Okay, so let's go back to our X11 container. So I did a really unequal display. If I do equal x authority, you see that my authority is inside here, and this is here. If I go back to Ubuntu X11 DevGem, and I do an echo of x authority, you see that it's exactly the same one. And this is actually the combination of these variables and these volume mounts are actually what allows it to communicate with the display server without having to create a privileged container. Cool. So this is a lot of stuff, and I forgive you if you got sleepy while I was explaining it, but I promise the next stuff is a lot easier. I did all this work here in the base container because this way I don't have to do much work for the other things. So let's see now how to configure a Firefox container and a Visual Studio Code container. Okay, so Firefox container, it's easy in the sense that Firefox is available in the Ubuntu repositories. So the general idea is just that you have to just install it, basically. And that's exactly what I'm doing here. So you see this, because I have Ubuntu X11 with everything, this Docker image file is very small. And basically what I do here, I just switch to root user, so user 0. I do a apt-get update to refresh the cache of packages. I install Firefox, and then I clean it up. Then go back to normal user. I make a directory bin where my entry point will be stored, and then I just pass the entry point. That's it. The entry point is also not very, the entry point is also quite simple. It's just, again, just an if. So the first thing it does, it refreshes the font cache. This is important in Linux, otherwise you won't see your fonts when you try to select them. And then if an argument is passed, Firefox will open with that argument. Otherwise, it will just create a new instance with the IP location address. So, okay, let's build this container. Build Docker Firefox. Of course, I already built it, so this was really fast. And now home in Firefox .gem. And there you are. Notice that I didn't start it in the interactive mode, so it actually launched in the background in the Docker daemon, so now my shell is free here. If I press Ctrl+C, it won't kill the container. And you see that I have, apparently I'm based in Groningen. At least that's what Firefox says. So yeah, this is just your Firefox, normal Firefox, nothing much, nothing else. And again, I could also pass another link to it, and now it should open to devgen.io. That's the same presentation you're watching. Cool. Okay. So Firefox is there. Visual Studio is a bit different in the sense that Visual Studio is not actually available in the Ubuntu repository. At least I couldn't find it. So the Docker file is still not very complicated, but it has some more things going on. Namely, what it does, what I did, I create a temp folder. Again, I switch to root. I create a temp folder, then use wget to download the release of Visual Studio.dev and save it in the temp folder, then update apt-get, I install it, and then I clean apt-get and remove the temp folder because I don't need it anymore. Go back to normal user, and like Firefox, I make a bin directory and I put my entry point in there. The entry point is very similar to the Firefox one because it just has, it's actually it's actually simpler because it just creates the fonts and then it runs code without a sandbox. The reason that I have to run it without a sandbox is because it's an Electron app and I would need to enable some kernel features in order to run it inside a Docker container with the sandbox. I don't think it's worthy in this specific case to do it. Definitely not worthy for this presentation. But in theory, you could launch it with the sandbox. And I pass arguments, of course, because that's always useful. So, okay, so I do home in build Docker Visual Studio build. So home bin Visual Studio.jam, it should just launch Visual Studio. You might have noticed that I'm launching this software, but they are not telling the things that you usually get when you launch things the first time, like Visual Studio asking you which theme to use, or Firefox begging you to make it your default browser, things like that. And the reason is because they have a home folder and they already launched these containers before. So in fact, if I go inside the workspace Visual Studio.jam, the directory looks empty, but it actually has a lot of files. Well, there's a lot of files in here. All the configuration, all the cache, everything you might want. So it's not like I start from scratch every time. Though in some circumstances, that might be what you want. Like you might want to not do anything, and that's okay. I have those cases as well, but I won't cover those cases in this presentation. Cool. So now we have a browser and Firefox running. That's not great. Like, yeah, it's a roundabout way to do something that you could do anyway with other technologies. So why go through this hassle? Why not just download an app image or make something else, right? And we will get to that. But first, let's take a small detour. Right now, you notice that I'm launching things from this home folder. This is not comfortable. I mean, I don't want to launch these applications as special applications. I don't want to notice their Docker containers unless I have to interact with the Docker image. So for that, in order to achieve that, I use a small tool called GNU-stau. And that basically it's a symbolic link manager. So it allows to mimic a folder structure in another folder with symbolic links. I will also show you that these containers actually support, well, I can't really show you audio, but I will try, and also webcam while you're looking at me, so probably it won't work, but I will try. Okay, so stau. Actually, I already stowed my folder, apparently, so let me remove it. Of course. Where am I? Oh, sorry. What's in the wrong folder? Okay. I messed up with my laptop, sorry. Okay, I will not uninstall it, but I already stowed all these things. And well, it doesn't work anyway. So when you install it, my home directory looks like this. I just want to show you. So I have a bunch of folders. I have a bin folder that is in the path, and all my scripts are there. All my scripts and applications are there. And then I have other folders that I use for different things. And if I do a tree of home, it mimics the same structure. So these things that are in bin, they will be, by using style, they are sync linked to the folder itself. So for instance, if I do ls on my home bin Firefox devgem, you see that it points to git devgem id home bin Firefox devgem. So it's the same thing that we see here. So why that is useful? Because this way I can launch Firefox in the same way that I launch any other application on my laptop. That's comfortable. That's a lot more comfortable than having to open a terminal. Well, if you had a different way to launch software, you can integrate it in a similar way. The style helps a lot for that. That's just a thing. It also helps keeping things managed neat and clean. So yeah, and what about audio video? Well, I can go to YouTube and let's see. Nice music, no nice music YouTube. Oh well.
Als je witte reus nog niet kent,
and you should hear to some audio. So thanks, witte reus. And you can hear that there is some audio going on. So audio works, YouTube works. Let's go to webcam test, and it detects the camera, so there is a video output 1. If I test it, it won't work, so I will stop my video, and you should see me from here. Hello. So you see, I have a Firefox inside a Docker container with camera working, and now you're kind of in Inception because I'm sharing my screen and we're looking at the camera, but that's what I want, and this is extremely useful for me because I can use this with Microsoft Teams, for instance. So let me close this and let me go back to my actual camera. So, you know, one problem I have is that sometimes I have to open multiple instances of Microsoft Teams with different accounts. I can just instantiate 2 Docker containers with 2 different accounts, and they will work seamlessly. That's great, amazing. And it's very, very comfortable for me. Okay, so audio works, YouTube works. It's integrated with my system. I don't even know these are Docker applications anymore, or I don't care. I just have to set it up once. So let's go to one thing that you can only do with this setup. So, which is when we start to introduce a VPN in the equation. So I think to anybody happened, if you're at a customer, you need to use a VPN. If you work for a customer, you need to use the VPN. And it happened to me that sometimes those VPNs are pretty slow, or they have some restrictions and I cannot listen to music or watching YouTube while browsing, while using them. Or even worse, I don't want to expose the VPN traffic to something that is not necessary for security reasons. And this setup actually allows to connect only some containers to the VPN, and others don't. So what I do, I actually have some applications that are connected to the customer VPN, but my main browser isn't. So I don't have any limitation, and it's also a bit safer, arguably. So okay, but how to set up a VPN without a privileged container? That's going to be fun. So as usual, we go to the Docker folder of NordVPN. I'm using NordVPN because I'm subscribed to it, but you can use any VPN, any VPN that is supported by Linux anyway. I did also containers with OpenVPN, for instance, that they work as well. So NordVPN is, so the basic structure is the same. We're just downloading the deb and installing it, nothing more. NordVPN has this thing that they have the deb that you download installs the repository, and then you have to install the VPN again, not VPN from the apt-get after the update. So basically, that's just what's happening here. Nothing more, nothing less. The entry point is a bit different than usual. So let's open the entry point. The entry point has two steps, actually. The first step is that it needs to start a NordVPN daemon, and this is started as root. And then once the daemon is running, and in this case I just wait for the SOC to appear, you can actually log in with your username and password, and then connect. Now, this container has a difference with other containers. It needs to be run as root. It should not run with your user, because in order to configure a VPN, you need to be root. I couldn't find a way around that, unfortunately. But it's not a privileged container, so I don't pass the privileged flag to it. So how I achieve that? Well, this is the first case in which those parameters extra actually start to matter. So if I go to home bin node VPN, now I have this .env file that overrides some parameters. So in my Docker extras, what I do, it's just I just load my credentials from a file, and this is just if it can't find credentials, it just exits. I create my credentials, and then I create the container. What I pass, of course, I pass a host name for the container. I set a UID, though I'm not using it. I only passing it as a variable in case I need it. I start it as root, so minus user 0. I pass the tune device, which is used to set up the VPN, and it has to have the net admin capability. This is really important. So this is what allows it to create a VPN connection without being a privileged container. It's partially privileged. It only has network admin capabilities. And of course, I have to pass my Nord username and password. That's as simple as that. So, okay, cool. So now I can just build it. So now I can just do build because I did my, remember, now the build script is in my path. I create the NordVPN. NordVPN is created. Now I can just call it with NordVPN.gem. I'm calling it in interactive mode because I didn't implement a way to keep it alive, so it would exit if I don't launch it in interactive mode. Of course, this is okay for this presentation. If I were doing it in my production machine, in my production setup, I actually keep it alive, of course. And I'm telling it to connect to Italy, though we won't always connect to Italy. Don't know why, but that's on NordVPN side. So you can see that just it started the daemon, creating the SOC, and I was logging in. Welcome, you can connect, and now I'm connected to Italy. Oh, cool. So what do I do about it? Well, I have created an instance of Firefox that goes via the VPN, firefox.vpn. Again, it has an environment on its own. So it has a small override of the environment, and the only thing that I do here, I just tell the container, I tell Docker, say, hey, for this container, as a network, could you use the network of the container that contains the VPN? So that means that now I have two Firefox. One Firefox that is connected to the internet, and a VPN Firefox that is connected to the VPN. So if I launch my normal Firefox, that's why I have IP location as a home, I am in Groningen. Okay, you should say so. But if I open Firefox VPN, last time I was in Romania. I'm in Italy actually this time. Great, so I'm in Milan now. That's fun. And yes, of course, this is a silly example. Like, although I do have a case with a customer that I have two browser instances with different VPNs, this is much more useful for other things like restricting access to using kubectl only to the VPN and not using for other traffic, or connecting your IDE to the VPN to access Bitbucket or things like that, or to access databases. You can package your SQL or whatever client you use for a database, connect it to a VPN, and that will be the only thing accessing the VPN. You won't go there. And That's mostly it. I wanted to show you also something about Vmet types, but I think we're running out of time probably. If we have some more time, I think I will just go super fast on this one. But basically, it's just to make it to further integrate it with the system. So I want that if I open a link, it opens in the Firefox inside the container and not in my main browser. In order to achieve that, you basically, in Linux, you configure config files. Well, we can close the VPN. So in Linux, you configure config files that in this case I have in local local share applications. I have this dispatch to URL that desktop. So you create a desktop entry and you specify the Mime type they can handle. Remember, because I use stau, now my local folder also contains this file. So if I do in my home.local share application, you see this dispatch URL to devgem that points to the URL. And now what I can say except bg mime, that is the command line argument to set a default handler for a default application for a schema. I say, hey, use dispatch URL to do this. Cool. What is this dispatch to devgem? Well, I'm opening this with that. So dispatch URL, what it does is if it detects that I'm trying to open the devgem URL, it opens the Firefox. Otherwise, it opens my normal browser. So I can say, okay, xdg open. That's just a way. Xdg open is just a command line to say open with the default handler. Please open devgem.io, and you see it launched Firefox, fully integrated. This is super useful, like when you have Microsoft Teams events, and you want to just click on the event link and open it in your Teams, but it's in a container and doesn't really work. There is more advanced stuff you can do, but I'm not going to do it now. I honestly didn't prepare it really well, and I think we're running out of time, and it's really a lot of information. But you could set up also that you try to open a link in a container and it opens in another container by using something called the XDG server. Themes are actually really easy to set up. If you remember in the base env, I mount the volume with the themes, and that alone is enough to guarantee that all the themes, that if you set a theme in your Ubuntu, for instance, it will be inherited by everything. Okay, so I suggest if you found this interesting, have fun with it, check out my project, try to build other containers. And if you have any questions, yeah, please feel free to ask. And this is everything I wanted to present.